Hello, everyone, and welcome to What's Up, the podcast where we talk about everything electrical and the future of the test and measurement industry. My name is Darcy, and I'm here to dive deep into some of the industry's biggest topics. Both static and dynamic testing is fundamental in transformer management. In this episode, our very prolific guest, Dr. Diego Robalino, is here with us to discuss why testing both of them is so important and how they complement each other. So let's find out what's up with Dr. Diego Robalino. Hello, Dr. Diego Robalino. How are you doing today?
Doing great. How about you, Darcy?
I'm doing fabulous. But I'm going to be even better when you answer the power-up questions for me. So I think you know by now what they are.
Yes.
Very familiar with them. It's 3 questions just to get you thinking and so we can learn a bit more about who you are. So are you ready?
I hope so.
Excellent. Okay. First question. Where is your favorite place you've ever visited?
Oh, so many places.
You're a well-seasoned traveler, I know. This might be difficult.
So many places, but I think that there's one place I just get amazed when I'm there, and that is Foz do Iguazu in Brazil.
Oh, lovely.
Yes, so the Iguazu Falls in Brazil. Amazing place.
And question number 2, what is your favorite Megger product?
My favorite Megger product. Oh, I love so many of those. My favorite one, maybe IDAX.
Oh, Good choice.
Yeah.
And question number 3, it's a this or that. So summer or winter, what do you prefer?
Winter in the south.
So it's basically like a British summer. Excellent choice. So Diego, we're here to talk today about static and dynamic testing when it comes to transformers. So can you quite simply just tell us what the difference is?
Okay. So let's start by saying that some of the definitions about the power transformer is considered to be static electric machine. With that being said, we will find that especially for power transformers where we need voltage regulation, we will have components, in this case the on-load tap changer or the automatic tap changer, that is in motion, right? So there's mechanical motion in the transformer. But besides that, there's oil flow internally. So there is motion, there's life in the transformer. Anyway, considering just static is one single position, no transition. And that can be related to specific type of testing that we will perform at one specific position, right? We may have a de-energized tap changer that is on one single position, right? And that will be the test. But if we have dynamic activity, in this case, the dynamics of moving and transitioning from one position on the tap changer to another one, that could be also looked into the testing protocol.
Mm-hmm. So when it comes to static testing specifically, what are you looking for and kind of what is out there to help you do that?
Well, when you look into static testing is don't move anything, okay?
Just keep it where it is.
Just keep it. You're absolutely right, Darcy. And one of the biggest problems that we have, especially when we talk about de-energized tap changer, right? Many people do not exercise that de-energized tap changer for several years. And when you come to test, please don't touch that DETC, that de-energized tap changer. Why? Because by moving it around, by exercising it, mechanically may not work well, right? So if you have exercised that continuously, that's fine. If you have not, you better leave it as it is. So you call the test as found, okay? So that is your as found test, the position of your tap changer. You are not changing absolutely anything. You do your connections on your bushings. You look into the electromechanical integrity or dielectric integrity of the transformer. But statically is because we are looking into just one single position, one contact point on the windings, okay?
So let's then flip it to dynamic testing. What are you testing for? What are you looking for? What's out there to help you do that?
Very good, because many things could look okay on a static position, right? So if I put my hand here and I put my hand here and I test this way, everything could look very good. But when I transition, right, from one point to another, is everything working fine? And that's what the dynamic test is looking at. This transition from one point of contact to the next one. Is that okay? Is everything that involves this transition? Because you cannot stop under normal operation, you cannot stop the current flow. If for whatever reason this current flow is stopped or broken, then you will have an arc. And arcing inside your transformer can deliver into failure. So that is the part that we're looking at, this transition, how this transition is working. And actually, just so you know, dynamic testing or dynamic resistance testing is something that probably did not start with transformers. One of our companies, our subsidiaries, Programa, right, started this on circuit breakers long time ago. And I think that they are the leaders on this dynamic testing on circuit breakers.
So it's not necessarily like a brand new thing.
The theory not, right? The transition, because the resistance is changing through this transition, that no. How this works on a circuit breaker versus a low top changer,
very different.
That is the different part. Yes.
As we know in this industry, there is always a measure of uncertainty. There are no true absolutes, right? So I'm going to ask a question now. Is there some middle ground between static and dynamic? So like quasi-dynamic or semi-static? Is it truly just one or the other?
You know, I've been in the industry for about 25 years plus. And long time ago, people did not have the tools that we have today.
Absolutely, yeah.
So the way to test this transition, right, was with a test that we call make before break. So before I tell you about make before break, just imagine how to check this transition that we always have current flow. So what the guys used to use in the field was a light bulb, right? So if you lose the light, then there's no current flow.
Then it's done.
Then
simple but effective.
So from that point of view right now, and we're looking into this make before break. So you make contact on the next tap position before you break on the original tap position. And that can be done as well. And I think that is the in-between, right? Your static test, right? And your dynamic test, because this will go on, this will look into the transition as well, a little bit in a different way without the details of the dynamic resistance test.
So in your opinion, are people favoring one over the other when it comes to testing? So are some people, looking more towards the static and not considering the dynamic, and vice versa?
I would say that depends on the application, right? If you have a de-energized tap changer, then you cannot look into dynamics. So there's a good amount of transformers that may not require this type of testing. And on top of that, you have your turns ratio testing. You can have your winding resistance testing. You can have your short circuit impedance testing. And you can have SFRA testing on the static point of view. And these technologies have been well identified, well verified, well validated, okay? And there's lots of history and there's lots of theory behind it. We have limits to understand, what's good, what's bad, right? Let's say your winding resistance, if you go over the 3% between different windings.
It's well established in that respect, isn't it?
Yeah, the standard calls for attention, right? It doesn't say, any standard is never going to say it's bad. It will say investigate. So you need to apply a little bit of common sense and look into the different technical approaches that you can practice in that transformer. But going back to dynamics in this case, if you have a voltage regulation system, right, you will love to understand what is on the dynamic point of view, because many things look very well just on the static side, but things fail probably on the dynamic transition. So everything looks good. And we have had situations where customers have come to us and say, my winding resistance looks okay, my SFRA looks perfect, my TTR looks fantastic, my, you name it. But it failed. So where was the problem? It was not on the static condition. It was on this transitioning, right, from one position to another in the tap changer that things fail. And that's what we want to look at. That's what we want to look into, the integrity of that transition point.
So is that how they complement each other then, that the dynamic side of it actually confirms the static testing?
They complement each other very well, right? Because just on the contact point, you may have an issue, right? And if you do just static testing, you may not see probably on the transition what's happening. So they absolutely complement each other. By knowing what is on the static and the dynamic side of the equation, you have a very good picture of the overall condition, the electromechanical condition of your winding.
So let's delve into the actual testing of how you would do this. So how would one go about doing a regime of both static and dynamic so they can get a full picture?
So on the static point of view, you have your turns ratio test, you have your winding resistance test, you have your SFRA, which actually gives you a very good picture on the overall electromechanical condition of your transformer. But then, if you want to go a little bit into the dynamic side, I think that there's basically three methods, right? You can go into dynamic voltage analysis, dynamic current, or what we have now, which is the true dynamic resistance. And why do we say true dynamic resistance? Because we're not just based on the voltage or on the current measurement, but we are really looking into the value of that resistance and the timing to do the transition. So we can compare the resistance value with what we have on the specifications of those transition resistors for that specific LTC or low tap changer.
So as great as it is to do more testing, and we know that's the best way to kind of maintaining your transformer health, unfortunately that comes with, as you know, like cost implications for buying more equipment and more, time that the engineers have to spend. And that's, to be honest, not really ideal, is it?
No, you're absolutely right. We can say that, as I mentioned before, depending on the application, you may decide to go with single function piece of equipment, and that will take several boxes that you need to carry around, with different pieces of equipment. Or you can get into a multifunctional piece of equipment, right, testing instrument that will allow you to perform all this static and dynamic testing with just one box. And I think that is the beauty of the multifunctional test sets. Like we have the tracks, right? You're familiar with the tracks 220, 280. With that device, we can go actually on all this fundamental testing, static, and in the advanced testing, we have included the dynamic resistance test.
Do you think people in the industry have a misconception about multifunction equipment, especially when it comes to kind of these higher voltage applications, that they're not as good as the kind of standalone single pieces of equipment?
No, I think that people understand the differences, and it's more a general practice. I'm used to drive on the right-hand side, right? When I come to Dover, I prefer to grab a cab, right?
Yeah, we're not going to let you loose on these roads.
But if needed to, I may drive on the left side, right? And I think that applies also to people. They've been used to do, say, single function testing. Sometimes they are reluctant to the multifunction piece of equipment because they say, if I lose the control, then I lose all the devices, right? I cannot perform any testing. But again, it's a feature, it's a tool, it's the way that you apply it, is how do you want to run it, right? Is it better for you to do separate pieces of equipment, separate functional tests, or you want to go into this multifunction piece of equipment? But the advanced testing is actually in the Trax 220, you can do your winding resistance test together with your dynamic resistance test, one shot. So
no time lost.
There are quite a few things that give you several advantages, as compared to just single function.
Yeah. So you've given us a really great overview of testing for both static and dynamic. Is there any resources or anything you want to point towards people? You want to point people towards so they can learn a bit more?
Yes. I think that there's quite a lot of material, especially on static testing that we have. But I will invite everyone to look into our library, our technical library in our website related to power transformers. We have many papers related to ratio testing. We have papers about winding resistance, SFRA. For those who are not familiar with all the information that we have in our website, we have the transformer life management editions as well, and those publications address some of these topics. And last year, together with Jafar Al-Durazi from our offices in Bahrain. We presented a paper at CGRE, GCC, talking exactly about this transition, and the complementary work that does static testing and dynamic testing. So actually that paper will be interesting for you to look at.
Well, I want to thank you so much for giving us that overview and delving deep into static and dynamic. I hope you enjoyed it.
I want to thank you very much for having this static guy here with a very dynamic conversation.
Oh, I could have done that sign up better if I did it myself. Thank you so much, Diego.
Thank you.
Thank you for watching and thank you for listening.